Konnichiwa friends, my name is Aisman Samasi and welcome to day 4 of the deep learning practice session. Okay, in this video we are going to see the theory part of the activation function. Okay, in the last day we practiced the how we stack the neural network layer one after the another. Okay, in this video we are going to learn the activation function, which is very much helpful, and it is inserted between the two layers of the neural network to make it non-linear. Okay, so first we need to understand what is an activation function. Okay, so in last video we talked about the difference between a biological and artificial neural network. Okay, so basically biological neural network, how it works: first it takes information, signal from all direction of the neurons. Okay, and here if the signal pass in particular threshold, then only it let the signal pass through it entire axon to the next neuron. Okay, so basically the signal only pass through the neuron only if the signal pass in particular threshold. Okay, for an biological neuron. For our artificial neuron, it also works the exact same thing. Okay, without activation function, a neural network is just a bunch of linear mathematics. Okay, like since the artificial neural network is based on the mathematics, we are basically stacking a mathematical function. Okay, so it can't basically solve an XOR problem. Okay, or like non-linear problem. Okay, so that's why we use basically an activation function just like our biological neuron. Okay, like here you could see that if you have an input tensor, we first pass it to an artificial neuron, then we pass that value to an activation function, and then we get any particular output. Okay, this activation function basically help us to learn the complex pattern inside our data set. Okay, so basically what does an activation function do to an tensor? Okay, so here you could see that we get an tensor from a neural layer. Okay, then we pass on to an most famous activation function named ReLU. Okay, and basically what it does is that it basically ignores all the negative value. Okay, so you could see here it's -2.0, -0.5, and we get here 0, 0, but it only considered the positive value. Okay, it basically only ignores the negative and it directly prints the positive value. Okay, so this is one example of an activation function. Okay, so here you could see that when you are stacking an mathematical artificial neuron, okay, we are basically stacking it together with another artificial neuron. Okay, so it's basically the same thing as we are stacking the neural network together. Okay, without our input value, but when we are using an activation function, it basically envelopes an artificial neural network. Okay, so with this artificial neural network plus an activation function, we get the real technology of our biological neural network. Okay, that's why it's very much important, and by this technique we could learn the curves we could learn the curves, edges, faces, speech and languages. Okay, basically activation function is what makes deep learning deep. Okay, this is the conclusion. Now the types of activation function. Okay, so we have 5 types of popular activation function. Okay, first is the ReLU. Okay, its mathematical significance is that it marks the 0 or the x. Okay, so basically it ignores all the negative value, and if there is a negative value, it always give the output as 0, just like here we get 0 0, and for positive value it directly prints that value. Okay, so here also it is done the same. Okay, -3 becomes 0, -1 becomes 0, and so on. Okay, and also this activation function is simple and very fast, so it's mostly used. Okay, and it is the default choice for our hidden layers. Okay, then we have our sigmoid function, which is basically 1 divided by 1 plus e to the power -x. Okay, and this basically gives an output from 0 to 1. Okay, here we get an output from 0 to our number. Here we always get an output from 0 to 1. Okay, so if you'll see the graph, you will see that the values from -infinity to infinity of the x value always lies between 0 and 1. Okay, it is basically used during binary classification. Okay, but here the gradients sometimes become very slow and sometimes even slow learning in deep learning. Okay, for the sigmoid, here you could see that we pass the 2 value -2 0 2, and when we put it inside this formula we get their respective value. Okay, then we have our tan h activation function. It's basically a new technology of sigmoid, where instead of getting value from 0 to 1 we get from -1 to 1. Okay, here both the ReLU and sigmoid doesn't consider the negative values, but our tan h functions make it possible to get negative values inside the our output. Okay, so if you'll see the graph, you will see the sigmoid work like this, but here the whole tan h go from -1 to 1. Okay, it is 0 centered as the mean lies in 0 only. Okay, but it still have vanishing gradient problem. Okay, then we have here fourth important activation function called leaky ReLU. Okay, so basically it is the same ReLU function, just that it leaks. Okay, like in water. So for example, it's here the ReLU functions ignores the whole negative value, but here the leaky ReLU function, okay, it adds a small x value into the negative axis. Okay, so for example, if it is a positive value, it gives our x, but if it is a negative value, it multiply the x with a small value. So we don't particularly ignore our negative value here. Okay, unlike ReLU, which completely ignores all the negative value. Okay, so leaky ReLU keep a small slope for negative. Okay, this one is done. And finally this softmax. Okay, so Softmax is basically used in the digital classification, image classes, or the NLP categories. Okay, it is generally useful during multi-class classification, and its solution is that we provide an input and it gives an probability that summation to 1. Okay, so if we'll add 0.66, 0.24 and 0.10, we get the probability equals to 1. Okay, so for each value it gives an probability. Okay, and the final prediction is based on the max probability. Okay, so here the max probability is 0.66, so the final prediction for classification we get is 2.0. Okay, so this is all about the 5 types of activation function. Here we have a simple box which basically compares the 5 function here. ReLU gives output range from 0 to infinity and it ignores the negative value. Sigmoid gives value from 0 to 1, tan h minus 1 to 1, local ReLU from minus infinity to infinity. Remember the small slope here. Okay, so it goes towards the minus infinity, and here softmax gives the probability that will be equal to 1. Okay, and is generally used for multi-class output. Key points you could see here. Now your question will be where we use activation function. Okay, so activation function is always used either between the layer or the final output. Okay, it is never used before the artificial neural network layer. Okay, it's never used before that. It always used after an neural layer only. Okay, so this thing you must remember. Now here in final output we use the activation function, but only it depends on the task we are doing. Okay, so for example, if it's a regression task, we never use an activation function. Okay, instead we use our linear artificial network layer. Okay, which gives an one output value here. Okay, we have talked this in our previous video. For classification, it depends on what task we are doing. Okay, so for example, if it's in binary classification, we always use our sigmoid output, but if it's in multi-class, we use our softmax. Okay, so do you know why we use here sigmoid and softmax? Please answer. So I hope you had answered it. So basically the answer is here, since in sigmoid we are getting value from 0 to 1 only, so here in binary classification we either get the 0 or 1. Okay, so for example, if it's between cat and dog, if cat get 0.8 value and dog get 0.2 value, okay, between 0 and 1 we get the prediction as cat. Okay, so this is how in sigmoid it is used. Okay, in softmax we get here in probability with which always outputs to 1. Okay, so here whichever values get the highest probability here is the prediction in the multi-class classification. Okay, so that's all for today. I know the lecture is short, but the practice session will be very long. Okay, remember it as with the stacking of the neural network and also the knowing of the activation function, we could now make a real artificial neural network. Okay, so now the last thing you should remember is that activation function changes tensor values. Okay, they add non-linearity. Without them, deep learning is useless. And here, out of all 5 activation function, ReLU is the king here. And finally, the output layer activation function depends on the task. Okay, this one, if it is regression, we use only linear layer only. Okay, not an activation function. But if it is in binary, we use our sigmoid. And if it is in multi-class, we use softmax. Okay, so that's all for today. See you in day 4 of the practice session. Okay, this may be small video, but believe me, the day 3, 4 and 5 is the base for neural network making. Okay, in weeks 6 to 10, you will really see the wonder on what you have learned so far. Okay, that's all for today. Thank you and take care. Bye bye.